So we are going to look at some examples of how to factor difference of two squares. So in the previous video, we went over how we got this formula. So let me erase multiplication not to confuse you of these two type of questions. So what you need to remember is factoring is reversing multiplication. So now this is what we are doing. So your answer of factoring should always be something times something. So that's the formula we need to memorize. Whenever we see a question that that is a difference minus of two squares type, we can always break it down or factor it as a plus b times a minus b. The easy way to memorize the formula is starting with the first one. How do we get a squared? A times a. How do we get a minus? Plus times minus. How do we get a squared? B times b. So now we're going to use the formula to factor these four examples here. First one, x squared minus 4y squared. We do see a minus. The first thing we want to do is to make sure it is the difference of two squares types, so we can use the formula, because we know there are other types of factoring that we can do. And so first thing, we have to determine which type of factoring it is. Now we can see that there is a minus, but that's the difference we need. And there is, we also need two squares. I do see a square and a square, but the important thing is we have to make sure besides the minus sign, there shouldn't be anything else. There should only be two perfect squares. And the first one is a perfect square, x squared. But the second one, there's a number 4 in front of it. So we cannot really use the formula directly. First thing we want to do is to rewrite the problem in terms of two perfect squares. So x squared, we're going to leave it as x squared. And minus the second one, 4y squared, we're going to rewrite it as something squared in the tail parenthesis. And so that will become a perfect squared. And now notice the 4 doesn't have a square yet. But if we do this, and we're going to get one thing squared. So what we do is we can rewrite, we know 4 is 2 squared. And y squared is the letter y squared. And again, this is reversing the process of multiplication we did it before. And we learned before, if we have 2y squared, we're supposed to distribute the exponent to each one, raise each factor to the exponent. So we got 2 squared, which is 4, and y squared, which is y squared. But to do factoring, again, it's reversing multiplication. So we are going to reverse 4y squared back to 2y parenthesis squared. So now we're ready to use the formula. So remember the tip. The formula is that you start with the first one, which is x squared. And how do we get x squared? What times what is x squared? So apparently it's x times x. And then how do we get a 2y squared? What does 2y squared mean? 2y squared, this 2 means 2 copies. 2 copies of what times what? It's 2 copies of 2y times 2y. So we can also get the minus sign first. The minus is plus times minus. And then we move on 2y to 2y squared, which is 2y times 2y. And we know 2y times 2y give us 2y squared, which will be 4y squared later. So this will be the answer. Now, let's look at the second question. The second question is a combination of two types of factoring we learned so far. One is GCF, the other is difference two squares. So when we look at a question, we notice it's not a perfect square because 3 is not a perfect square. But we do notice it has a GCF. They both have a 3 in common. 3 goes into both of them. So the first thing we want to do is to factor out of 3. And there's no x in common, so we're going to keep it. How do we determine after you factor out of 3? A quick way you can do to determine the other factor is to divide everything by 3. So we divide the first term by 3. 3x squared divided by 3. This 3 cancels 3. That leaves us x squared. And minus, it's negative 3 divided by 3. That gives us minus 1. And now 3, the number 3, we're going to keep it. But x squared minus 1, we need to check whether it is still factorable. If it is not factorable, we can leave it. But if it is factorable, we do have to factor it further. And by looking at this, I recognize it is difference of two squares, because there is a minus here. There is a square we need another square, but we can easily rewrite 1 as the perfect square, because 1 is also equal to 1 squared. The first thing we do is to rewrite it. 1, we can rewrite it, replace it with 1 squared because they're the same. And now we can use the formula. Notice that 3 is the common factor we factored out, so we got to keep it from the beginning to the end. Now let's apply difference of two squares type just on this part. So x squared means x times another x. And how do we get that minus sign? Has to be a positive times a negative, or negative times positive. How do we get 1 squared? It's 1 times 1. The times is between the parentheses, which is omitted. We can put it there, a dot there, or you can omit that. And that's the final answer, because we cannot break down x plus 1 or x minus 1 any further. The next question we're going to look at is example 3. So in example 3, we do the same thing. Any factoring question, first thing we want to try is to factor out the greatest common factor. And we notice that 5 goes into both of them. So we're going to factor out a 5. And after we factor out a 5, we know we get 4 minus x squared. If you have trouble seeing it, doing it in your head, you can do division like we did in the previous example. So if you determine, after determining 5 goes into both of them, you can divide each of them by 5. And as we can see, 20 divided by 5 gives us 4. And negative 5 divided by negative 5 gives us a negative 1. That 1 is omitted. And x squared will be by itself. Again, we need to determine whether this can be factored further. And usually, when we have x squared, it might be able to we might be able to factor it further. And we checked, and it is difference, and it is 2 perfect square. Although 4 right now is not a perfect square, in that not the form of perfect square, but we know 4 is a perfect square, which is 2 squared. So we rewrite 4 in 2 squared. The reason we do that is because we want to use the formula. You can do this step in your head if you can. So now we're going to use the we apply the difference of 2 squared formula just on that. And that 5, we just bring it down. So now we're going to try to come up with the 2 squared, which is 2 times 2. And we're going to try to come up with the minus, which is plus times minus. And we try to come up with x squared, which is x times x. And that's the answer of this one. The last example, number 4, it's the most complicated one because we have to use the difference of 2 squares formula twice. So the first thing we're going to do is to rewrite both of them in the difference of 2 squares form so we can apply the formula. And again, if you can do this in your head. As we know that x to the 4th, by reversing multiplication, it's x squared squared. So if you memorize the formula of the power of power formula, when you raise the power to another on top of another power, you multiply the 2 powers. So 2 times 2 will give you a 4. So again, we're reversing multiplication. Now 16 is 4 squared. So now we have two perfect squares. We can apply the formula. So again, the formula says it's like, so here is a little tricky because we got 2 copies of x squared. So we're gonna do x squared, 1 copy here, times another x squared here. So that's x squared times x squared. And to get that minus, we do plus times minus. To get that 4 squared, we have to have 2 copies. 1 here and 1 there. So 4 times 4 gives us 4 squared. Now we got to continue to check whether we can factor each one further. The first one, there's no GCF, and it's not a difference 2 squared because it has plus here. So we cannot factor it any further. So we keep it as x squared plus 4. But the second one, x squared minus 4, we know that is also difference 2 squares because that 4 can be written as 2 copies of 2. So we're going to rewrite that 4 as 2 squared. Oops. The reason we're doing this is so we can apply the formula easily. So now we keep bringing down this x squared plus 4. And that x squared minus 2 squared, we apply the difference of 2 squares formula again on that. That gives us x plus 2 times x minus 2. Because x times x will give us that x squared. Plus times minus will give us that minus, and 2 times 2 gives us 2 squared.